Hi viewers, myself Dr. C. Vijay Kumar, Associate Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tiruchendur. Today we discuss about the module of solid-based additive manufacturing process. Previous class we discussed about what is the rapid prototyping process and what are the process under the classification of RPT, then what are the process under the liquid-based additive manufacturing process. All the points are discussed. Today we discuss about the solid-based additive manufacturing process. What is the principle behind that? What are the category of different process under the solid-based additive manufacturing process? All the things are discussed today. We see one by one. First one is the what is meant by solid-based additive manufacturing process? Solid-based rapid prototyping process is now designed to work with all solid-state materials. The solid form could be in the form of a wire, laminate, pellets, or a roll. Solid-based RP systems works on the following principles: cutting and gluing and joining method. The only additive manufacturing method which involves whole solids instead of liquid or powder form. First, very thin sheets of desired material have stacked layer by layer using suitable adhesives or ultrasonic welding. In the solid-based additive manufacturing process, we see the first one is the laminated object manufacturing process. What is the laminated object manufacturing process? Then fusion deposition modeling process. These are the different types of process we discussed. First we discuss about the fusion deposition modeling process. What is the principle behind that fusion deposition modeling process? The basic principle of FDM technology is the process of making physical objects by building up successive layers of materials. A thermoplastic filament is pushed through an extruder and deposited where needed in each layer of complete the desired object. If any extrude material, extrude projection or extrude part is there in our product, then we can create a support structure also possible. This is the principle of fusion deposition modeling process. What are the materials used in the FDM? FDM utilizes strong engineering grade materials like ABS, polycarbonate and Altum 9085 resin in engineering resins for specific mechanical and thermal properties. Next we see that this is the whole entire setup of fusion deposition modeling. We see we have different types of pools. One is a build materials pool, then another one is a support structure supplying materials pool. These are the two types of pool. Then we have two different nozzles. One nozzle is the extruder, the built material extruder. Another one nozzle is support material extruder. This liquefier head, we say that the whole setup is liquefier head. The liquefier head is controlled by servo motor by moving the direction X and Y. This is the part built up area. The bottom one is a built up platform, then foam slab, then we create a layer by layer object. Then this is the built material platform is moved up and down direction, that is called as a Z direction, it's moved. Once the setup is on, the liquefier head is supplied. Once the user is needed the built material, the built material jet is on, the built material is supplied. Then if any extension part is there, suppose if the user is needed the support material, then extruder nozzle will supply the extruded material. Once the first layer how it's built, the platform is a starting position. First the built material is supplied through the liquefier head. The first layer is formed, then it gets solidified. Then again the built platform is moved in Z direction down. It go down the next layer thickness. Then next the supply material is supplied through the liquefier head. The next layer is formed. The next the cycle is repeated. Once the entire product is developed, the process is continued. Once the full product is prototype is completed, the machine is switched off. This is the process of fusion deposition modeling. You see the next diagram. This is the 3D view of fusion deposition modeling. This is the liquefier head. The liquefier head, two different types of extruder. One is a supply material extruder, another one is a built material extruder. Once the switch on, the supply material and support material is ready for processing. It's based on the user. Once the user is needed the built material jet is on, the built material is supplied to the platform. Once the initial layer is created, then next process is continued until the process or product completely finished. The process is cyclically repeated. This is the fusion deposition modeling process. These are the working principle of fusion deposition modeling. The fusion deposition modeling was developed by the Starway and Minusa. In this process, the plastic or wax material is extruded through a nozzle that traces the parts cross-sectional geometry layer by layer. The built material is usually supplied in the filament form, but some setups utilize plastic pellets feed from a hooper instead of nozzle. The nozzle contains resistive heaters that keep the plastic at a temperature just above its melting point so that it flows easily through the nozzle and forms the layer. The plastic hardens immediately after flowing from the nozzle and bonds to the layer below. Once a layer is built, the platform lowers and the extrusion nozzle deposition another layer until the project completed. The process is cyclically repeated. The layer thickness and vertical dimensional accuracy is determined by the extruder diameter, which ranges from 0.013 to 0.005 inches. The XY plane 0.001 inch resolution is achievable. The range of materials are available including ABS, polyamide, polycarbonate, polyethylene and polypropylene and investing casting wax. These all are the process of fusion deposition modeling. The next one, advantages and disadvantages of FDM. In each and every measuring process, we have some advantages, some disadvantages. The same line we discuss about the advantages of fusion deposition modeling. The fusion deposition modeling technology is affordable. Then FDM works with many materials compared than other processes. FDM models can be very detailed. FDM filaments are not easily contaminated. You can print large materials also possible in this FDM process. The fusion deposition modeling is easy. FDM is relatively fast. Then limited detail is available for this FDM process. Then disadvantages of fusion deposition modeling is the FDM is only used when few low-speed channels are desired. The FDM systems are extremely expansive. These are some disadvantages of FDM. So take home points, the FDM, the fusion deposition modeling, the principle is we supplying in two different type of material in liquid state. One is a built material, another one is a support material. Both the things are joined in a liquefied head. When the user is defined whether the supply material is needed or support material is needed or built material is needed. Once the built material is needed means then in the liquefied jet is supply the built material into the basic platform. The first layer is completely manufactured, then the platform goes to Z direction, the next layer is started. The cycle process is repeated until the full project is completed. Okay. These are some points of FDM, fusion deposition modeling. So thank you for watching. Keep learning, keep growing.